So I kind of want to take a minute and talk about how we're going to take this, what we've been doing, and make it into something that you guys can hopefully reuse for any games that you guys are going to be making. We have a few problems with the way that we're structuring this logic. We have a lot of this logic for our shooting and for our moving and for our bullet creation inside of our main function here. So one of the paradigms I kind of want you to follow as much as possible when you're making your own programs is to make sure that your main function here is actually as small as possible. You don't really want a lot of code in here. If you're writing your code correctly, your main function is literally just going to be like a return at the bottom for whatever you want, and maybe some setup for your logic for like SFML, for instance. And that'll be it. We have a lot of logic here for like player movement and bullet shooting here. So instead what I want to do is I want to take all that logic that's responsible for player shooting and put it into the player. And I want to take all that logic for player movement and put it into the player as well. And I want to take this list of game objects that I have here, and I want that to live somewhere that I can access it from within the player and from within the bullets as well. The reason is that we're going to start making asteroids, and we need to do collision detection. And collision detection for asteroids is a little bit more involved than Pong was. The code is actually more simple. In my opinion, I think the code is more simple. However, you have to think about how we're going to organize what our collision detection is. So let me draw you guys a little bit of the diagram for how I want to set up the collision detection for our game. Let's talk a little bit about what Asteroid's collision detection is going to be like. Okay, so here's our player. We're going to have a bunch of bullets associated with the player, right? And then we're going to be creating asteroids as well. Let me use these as asteroids here. And these asteroids are going to be of many shapes. So how does collision detection work? So there's a few rules about collision detection with asteroids to make it work here. What are the rules? What collides with what in asteroids? What things can collide with each other? Can we talk a little bit about that? Okay, so the player collides with the asteroids. The bullets also collide with the asteroids. What about the asteroids with the other asteroids? Do they collide? Theoretically? Not in asteroids. In the actual game, they don't.
No, they don't.
What about bullets with bullets? No. Okay. So we need to have some conditions here. Our logic here for determining what collides with what is going to be, I can't just write one function and have everything use it. Otherwise, when asteroids hit each other, they would just blow up, right? So I need some concept of filtering is one thing. I need to make sure that bullets only collide with asteroids and that asteroids only collide with other asteroids. Eventually, too, I'm going to have things like UFOs, which UFOs shouldn't collide with asteroids, right? They shouldn't get blown up by it if they're AI. The way that I want to set up our collision is actually going to be pretty simple for asteroids. We're going to just use a circle collision here. So if I were to actually draw a box around this, if I were to represent our asteroid collision, we're going to represent every single thing that has a collision box with a circle, like so, including our player. Our player is going to have a circle, and our bullets are going to have a little radius as well associated with them. And then every asteroid is going to have their own collision radius. The way we're going to set this up is that we're going to create the concept of a game engine. And our game engine, the way it's going to work is it's going to go over every object and see if it collides with any other object. So if I take this, for instance, I'm going to make a few examples here. Take this bullet here, put it inside that other asteroid. So here's how the logic's going to work. We have this list of game objects that live inside of our game. Currently, it just has players and bullets inside of it. We're going to add the concept of asteroids too. But ultimately, we have like a big list of like asteroids. If I give each one of these asteroids a name, I call this like, let's say here, Gary. I want to call this Gary.
Asteroid Gary.
That's Gary. He's a little big. Here's Gary. Okay. This one's going to be Frank. It's going to be Megan. You guys ever see the Key and Peele sketch with Megan? And Megan. It's Megan. Megan. You guys don't know Megan? Shake Quellen. Okay, I'm giving these guys names. I'm going to give the bullets names too. What should the bullets names be? This one's going to be named John. And then this one's going to be named Paul. Sorry, Paul, you're not here, so I'll get to use your name. All right, so the reason why I gave these guys names is we're going to go over and talk about how we're going to write our code to handle collision detection. And that's going to help us figure out how we're going to architect our engine to represent these objects and how to write the code to actually do this behavior. So here's the logic. I'm going to start with Gary, okay? We have a list of all these guys that live in our game object. I'm just going to create a list here. This is going to represent the list of all the objects in our vector that we have. We have Gary, we have John, Paul, Pete, Frank, Carol, and Megan. Okay? This is actually the list of objects. They all have a slot in the array. If I were to draw a little line to represent, each of these guys has their own little slot in our list of game objects. Right? This represents our vector of game object pointers that we have. Each of these characters that we've named represents a game object pointer. Some of these guys are bullets, some of these guys are players, but they all live in the same list. So we are going to start with Gary. And we're going to say, hey Gary, we're going to start with you. We're going to pick you. And we're going to go over every other object that's in the list, and we're going to see if you're overlapping with that object. So we're going to start with Gary, and we're going to save Gary off. Okay, we're going to say like, okay, we're going to start with you, and we know who we're currently working with. Then we're going to say, okay, Gary, are you currently overlapping with John right now? And we're going to see that Gary's collision radius up here doesn't overlap with John. We are caring that they overlap because John is a bullet and Gary is an asteroid. And if those two guys, they hate each other, Gary and John. John himself says, okay, well, I'm a bullet, but I'm nowhere near you, so you don't have to worry about me. Paul says the same thing. I'm going to go down this list and say, hey, Paul, are you colliding with Gary or not? So I keep going down this list and comparing, like Pete, who's a player, and Frank. We get to Frank, though, and Gary and Frank are good friends. I feel like this is like elementary school. Gary and Frank are good friends. Gary and Frank are both asteroids. Gary says, hey, are you currently overlapping with me, Frank? And Frank says, you know, you don't really even care about that. You know why? Because I'm an asteroid too, and you're an asteroid, and we don't really collide with one another. So then it says, cool, I don't need to worry about you, I'm going to keep going. Goes down to Carol. Carol also says that she's an asteroid, and we keep going. So we went through our entire list, starting with Gary. Gary says, hey, was I colliding with any of you? And he says, everyone says no. Cool. Now we have to repeat this behavior with John. So John goes next, okay? John is a bullet. So John, we say, okay, John, we're going to need to test to see if you're colliding with anyone else in the level. So in this case here, I'm going to leave John where he is. And John's going to, we're going to move this purple thing around. This purple object's going to represent the thing we're going to test John against. So John's going to have to ask Gary to see if he's colliding with him. Okay? Gary says no. Even though we asked him before, Gary has a short-term memory loss, so he doesn't really remember. John and Gary say, hey, I don't really collide with you. Our radiuses aren't overlapping. And then we get to John comparing himself to himself. And we say, hey, John, are you overlapping with yourself? There's a rule there that says, hey, you can't collide with yourself, right? That's another rule. So John says, oh, I'm just going to skip myself. So I'll go to the next guy. Paul and John are both bullets. John says, hey, I'm a bullet. Paul says, hey, I'm a bullet too. You can skip that guy too. Get down to Pete. Pete is a player. As we know, bullets don't interact with players. So Pete says, hey, I'm a player. John says, okay, I can ignore you too. So really, John's asking a couple questions every time he goes through. He's saying, hey, are you an asteroid? That's what he cares about. And then if you are an asteroid, are you colliding with me or not? So then we get down to Frank, and Frank is an asteroid, and he doesn't collide with him. And we go through this list again. We're going to repeat this behavior until we get into, I'm going to name this guy here. This guy's a rebel. What's that?
No name.
No name. I'm going to name him Joe. So we're going to add Joe to this list here. Okay. So we get down, and there's a couple of interesting things I want to note here. I'm going to get to Frank here. Frank is the asteroid we're carrying against. And Frank doesn't collide with any of these guys, right? Except when he gets down to Joe. So Frank says, hey Joe, you're a bullet. Yeah. Are we overlapping our collision? Yep, we are. Those two questions have been answered truthfully, yes. So now Frank and Joe have a collision. What do we need to do here in this case? Well, there's a few things we need to do. One, we need to eventually, the asteroid needs to blow up, right? That's one thing. So Frank needs to blow up. Joe is a bullet. He needs to just get destroyed because he hit an asteroid. So he needs to go away from this list. Now, to be fair, the way we're doing our collision detection, we kind of wrote it in such a way that everyone gets a chance. Everyone gets a chance to ask. So what happens? Let's just imagine that we want to blow up Frank and we want to blow up Joe. However, we still have to go through this list to go over everyone. What happens when we get down to Joe? Let's say we already detected that there was a collision and we save off that information for later. We get down to Joe, and then Joe says, hey, when I went through my list, even though the arrows flipped, we still had a collision. We have this condition to worry about too, where we went through that list and we finished with Joe at the bottom of the list, and we detected that he also had a collision with Frank. So we have to be mindful of the fact that while we're going through this list here, we can't really be, we have to be considerate of the fact that some people may have detected a collision already with one another. So here's what we're going to do to solve this case. Here's how we're going to architect our collision detection and how we destroy things. When we get to Frank here and he detects a collision with Joe, we're going to do a couple of things. One, we're going to set a property that says, hey, Frank and Joe, both of you guys had a collision, and so both of you guys, I'm going to set you up so that you're going to get blown up. But we're not going to do it right now. We're going to set it up later. And I'll show you why. So I'm going to put a little flag here. What is that? Put a little flag here that says, hey, Frank, you're destroyed, you get a blue star. Joe, you're destroyed, you get a blue star. What that star is going to mean is I'm going to set a property on their class that says, hey, you've been destroyed. And when you have that property set, you are now exempt from all other collision tests that happen. It's as if you don't exist in this list. Now, the thing we want to avoid is we really want to avoid modifying this list as we're going through it, because the way that C++ works, if you're going through a list and you're removing and adding stuff to that list, it gets very hairy. It actually gets potentially dangerous, and you can cause crashes if you're removing things and you're changing the size of that list while you're looping through it. So all we're going to do is we're going to set a little flag here that says, hey, Joe and Frank have had collisions. Then when we get down here and it's Joe's turn to do collision testing, Joe says, oh, well, I've already been destroyed. I've already been flagged as having a collision with someone, so I'm just going to ignore my step. I'm just going to keep going. And anyone else who would be asking Joe if he collides with him would also say, oh, you're already destroyed. I can ignore you. So this whole concept, this list of things, is our vector of game objects. We have, even though we've given names to these guys, this list lives somewhere. Now, the only way that this list can actually do stuff based on behavior is we have to have that list live in a place that these objects can ask each other about. Okay? Okay. So here's how we're going to organize our code. Our structure of our objects kind of looks like this right now. We have a I'm just going to draw the our objects that we have. We have a player. We have, this is not a hierarchy. It can be. Yeah. Let me draw bullets. And then we have our game object here, which is the parent class for these two. So we're going to add a third one here for Asteroid. That's the first step we're going to do. We're going to create an asteroid here that we can spawn. And it has a lot of the same properties as a bullet and a player, like so. So the problem here is that where's our list of game objects living right now? It's actually kind of living like out here. It's kind of living out in the middle of nowhere here. We have this thing that's like a game object list. It's living actually, if you look at our code, it's living right here. It's inside main. What I want to do though is I want to follow that paradigm of I want to move as much of this stuff out of main as possible. I want to move as much of this stuff into the relevant classes that need them. So I want to take this game object list here. I don't want to make it part of the main. I want to make a new object. I call it my game engine. And this game engine is going to have a few properties to it which are going to make it a little bit easier for us to manage. This game engine is going to have within it a list of game objects. It's going to live as part of this game engine. We're going to move it out of main and we're going to put it inside of our game engine. And our game engine is going to be the one that handles notifying collision detections as well as things like adding or removing objects to our game. The reason is that, let's say for instance, I'm going to show you why this is a problem. Let's say I wanted to actually move the spawning of the bullets, which are here right now. So when I press the keyboard, let's say I want to move this so that we spawn the bullets inside the player instead. So let me try writing that code, and I'll show you why this is actually problematic and I can't do it. So I'm going to go down to my class where my player is. I'm going to write some code here. Like so. And I'm just going to say, hey, I'd like to create a bullet. All right, I've made a bullet. But how do I add this bullet to get drawn? How do I actually draw this bullet? Well, this is kind of a problem. Watch what happens, right? So I have my asteroid here, or my ship, and I'm shooting spacebar normally. Those are my bullets that I've created earlier. I'm going to get rid of all this code here. Comment this out for now. And I'm going to print every time I hit spacebar, I'm going to print something out to the screen. Oh, let me also get rid of that print here. Okay. So I'm pressing spacebar, and you can see on the left, I'm trying to spawn a bunch of bullets. Now I'm actually making these bullets. Watch what happens if I show you how much memory is currently being used by our game. This is kind of a weird way to show how this is working, but I'll show you. We go to our engine CPP. Can you guys see that memory usage? That thing that I've highlighted is actually going up right now. Like my memory usage is going up and actually won't stop. Like even if I let go of spacebar and just let it go, like it won't clean up, it won't recover. Because I'm actually making these bullets. I'm actually asking for memory for these bullets. So I'm at 100 kilobytes of RAM taken up right now. The longer I hold spacebar, the more bullets I'm spawning. But these bullets aren't destroying themselves, and these bullets aren't drawing on screen. So I have a problem because I'd like to actually create those bullets on the player. So what do we usually do when we create a bullet? If I go to my code, whenever I create something, this guy right here, like so, I call game_objects pushback. This is the key to actually creating our bullet. By adding it to the list here, this list is getting updated here and getting drawn here. So I need a way to get my bullet that I created inside my player update function, which is all the way, if I look at my diagram here, my player update function is all the way over here, and my game object list is all the way over here. Like these two things, this guy right here, this game object list is completely separate from this guy over here. They have no knowledge of one another. That's the main problem that we're trying to solve here. So what if we took this concept of this game object list, and we gave the player a connection to this game engine. Now, when I'm not talking about deriving a class here, I'm going to actually represent this guy with a different color. I'm talking about, hey, why don't we have the player have a pointer to this game engine? So this game engine that we have here can be stored off and pointed to by any of these things. If we had a pointer to the game engine, we could actually add bullets to the list. So let's do this. So that's why I want to move this. That's why I want to take this. I want to take this array and I want to put it somewhere else. I could put this thing inside of our player. For instance, I could have the player, if I go to the header file for the player, I could put it here. I could definitely put a game objects member variable here inside player. And then I'd also have to put one inside a bullet as well. I could do that. But instead of duplicating this game objects array everywhere, I'm going to have one thing that has this list, and I'm going to point to it instead. Let me show you what it looks like if I put this here. If I had the player have this game objects list, what I would do is I would go to this update function. I'd have to do something like this inside the player. And I'd have to do something like this for drawing as well. And then I have to duplicate this code everywhere that I have an object. Let's remove this whole idea. Let's just talk about how we move this thing to somewhere that makes more sense. So let me just clean this up a little bit. And what I'm going to do is I'm going to make something for you guys that's called a game engine. It's not really, you guys might have heard the concept of a game engine. Like, for instance, Overwatch obviously runs on a game engine. Unreal is a game engine as well. But we can make a game engine ourselves. The idea of writing a game engine is actually pretty straightforward. There's a few things that you need for a game engine to make it work. You need a way to update and you need a way to draw. And typically, you also have a list of things that you'd like to work on. So I'm going to make a class called a game engine. So our game engine is going to do pretty much 3 things. It's going to update all the objects, it's going to draw all the objects, and it's going to give you a way to add new objects to that list. Okay? So we're going to create a couple of functions here, one for update and one for draw. So I'm actually going to take these functions that were in our base game object. So those are 2 of our functions that we need. We don't actually need these things to be virtual at all, because nothing's going to be deriving off game engine in our case. Our game engine also is going to have that list of objects. So I'm going to take this list from main here, I'm going to cut it out of here, and I'm going to put it right here instead. Okay? I'm going to call it m_game objects. I just moved it from main to be a member variable of here. Okay? And then we're going to give you a way to add new ones in here. So here's our game objects list. And let's just work with this for now. So I moved that out, so now I have a bunch of errors here. But how do we actually create our game engine inside of our main function? Remember, I want to be able to move all this code out of our main function and put it inside of our player. Really, you just need to create one. Call it my awesome engine. I'm going to call this Unreal Engine 5. It's a secret, because actually let's just call it Unreal Engine 6. They're probably already working on Unreal Engine 5, so we have to get ahead of the game, right? We can't just go to the next number. That'd be too obvious.
Like Diablo 5.
Oh, Diablo 5? No, this is an engine, so it has to be like, it's not a game, so you have to think of it like Unity or like Unreal or something like that, right? It starts off really small, and it's only 2D, but who cares? We're making Asteroids. Now, the thing is that this game engine we can use now. We can actually use this Unreal Engine 6.addObject. So we can call this function addObject. Remember what we used to do. Let me just do a comparison. Instead of doing game objects push back like this, I'm going to call Unreal Engine 6 addObject player. These 2 lines of code are going to do the same thing. But I'm going to take this, I'm going to remove it from here. And I'm going to rely on this function, add object. Now, if I go to my header file for this game engine, I have this function, but it has green squigglies under it because I haven't implemented it yet. So I can take this function, copy it, and I can go to my game object CPP, go to the bottom here, I'll put a bunch of these. This is kind of a common thing that we do, at least on Overwatch, to do separation of classes. So there's our add object. And we just have to decide what we want to do with this. And really all we're going to do is we have our array of game objects, and we're going to push back the thing that we pass it, like so. That's all this function does. The reason why we need this function is because this is private. Okay. So let's take these next 2 functions and write them as well. Same idea, like so. Now, we can actually just take the code we've already written for this. If I scroll down here, and I take this guy right now, I'm going to take him out of here, and I'm going to put him right here, like so. And instead of this thing as seconds, we'll pass this in like so. Okay. So now our game engine, if we call update on it, it'll go through all of its objects and update them. And then we're also going to do the same thing for draw. Window. I just copied this code and put it into here. Okay, our game engine is taking shape. We'll be able to sell it for millions soon, I'm sure. Okay. So what we can do now is we can call game engine, or what we call the Unreal Engine 6 update, pass in the delta time, and we could call Unreal Engine 6 draw, and we could pass in our window. And every place where I was calling push back before, I'm going to replace it with Unreal Engine 6 add object. So you can see here what I did here was I called add object. And I'm just going to replace all the red squigglies here with add object instead. Like so. And like so. One more thing we needed to do is this loop that we wrote actually is responsible for managing the list of objects that we want to destroy. Let's move that into our update too. We've got to move this as well. I'm just going to replace all these here. And I'll give you guys this, because we're about to do a lab with this work, so I'll give you guys this to be able to work with. Okay. I'm just going to run this code. Hopefully things will draw. Nothing is drawing, which is great. As you expect, there are obviously some issues with this. So let's just double check here that we're actually drawing everything. So we have this problem. We didn't actually, this wasn't fixed up. We have this variable. We need to make sure we're calling the correct variable. And there's our player. Everything rotates. It looks exactly the same. Seems like a lot of work to do for like making something look exactly the same, right? But by moving everything, we have now given ourselves the ability to have the player be able to add objects himself. Okay, so let's do that. We're going to take this. First of all, I want to make sure my bullet speed is correct now. I'm going to actually make them spawn reasonably fast. Okay, there's our bullets. I just sped them up. All this logic here, I want to move into the player. So going back to my diagram here, if I want the player to be able to add an object to this list, the player has to have a way to get to the game engine, right? So when I do this, I want to have the player have a pointer to my game engine. Okay? So here's what we're going to do. We're going to make a pointer to a game engine right here. This pointer to a game engine is literally just going to point to the thing that has all the list of objects. I want to point to it. This guy here, I'm going to initialize every time we add an object to our list. The problem here is that I'm trying to compile this right now. So what is the issue that it's having? It's giving me a really weird error, and you guys might see this error at home when you're building your projects. It says missing semicolon before this asterisk, and this is like one of the worst error messages that exist, which is, hey, it says you're missing a semicolon here. So like what? Are you supposed to put a semicolon here? Or like put a semicolon here somewhere? That's actually not what the error is. The error is actually 2 down from here. It says unexpected token preceding the semicolon. Well, the problem is, look, C++ compiles stuff from top to bottom, right? It gets to this class for game object, goes down the list, says, oh, you want me to use this pointer called game engine. But where is that thing declared? It's declared down here at the bottom. Okay, so we could move it up, like so. But now we have a different problem. We have game engine here that's relying on game object. So this thing is supposed to point to here. So I'm going top down, and I have this catch-22 problem, right? I have this problem where game engine needs game object, and game object needs game engine. They both need each other. So how do you get around this problem? This is actually a very common issue, where you have two things that need to know about one another, but you haven't quite finished writing that object. The way you solve this problem is you give the game engine here, you give them a promise that says, hey, I promise you that there's something called game object. It's just going to show up a little bit later. Bless you. So we're going to do what's called a forward declaration. We're going to declare that something exists before it actually exists, with a promise that it will actually show up later. The way you do that is you look at the thing that this game engine needs. For instance, this game engine needs a game object. And we say, okay, I'm going to tell you what this game object kind of looks like. And this game object to me looks like a class. So what you do is before you actually create this class, you say, hey, I want to forward declare that a game object exists. And it's of type class. And this is all you do. You put the word class, and then the type of name it is, the game object in this case, and then followed by a semicolon. This forward declaration tells C++ to say, hey, defer processing the rest of this file and assume that the game object will be declared eventually. So say, okay, don't worry about declaring an error right away. Just I'll let you know when it actually shows up. Okay. So now when I build, it builds successfully. So if you guys ever see this error that's like shows up and the error says something like undeclared identifier or syntax error identifier game object, you look at the name here and you realize that going top to bottom it doesn't know what this thing is in either of these cases. Okay. Okay, so we take our add object call, we have passed in a game object. So going back to our engine here, we have a player and we call add object for the player. The player needs to be told about this guy right here. The player needs to be told about where Unreal Engine 6 is, because this little guy right here has all of our objects in him, has our list of objects. So here's what I'm going to do. I'm going to go back here to my game object. It has a pointer to an engine. I'm going to create a function here that's called setEngine inside my game object. Let's declare this guy. This guy right here. All right. And all we're going to do is we're going to say, hey, your member variable for engine is this guy that's passed in. We're going to scroll down to the bottom where we call add object, and all we're going to do is going to say, hey, setEngine, and we're going to pass in a pointer to the engine. We can't do Unreal Engine 6 here, though. What if we pass it into here? So what's nice, though, is that C++ will give you it gives you a variable which you can use for this case. Every time you call a function that belongs to a class, it injects a secret hidden parameter that's called the this pointer. You can actually use it. It's just called this. It's secret. It only works if you call on a function that lives in a class. This thing gets automatically added, and what this means is that, hey, this represents a pointer of whatever object you're calling the function on. So in this case, this thing here, this pointer, represents the game engine. which, if I go to where we call this function on, is this guy right here, is Unreal Engine 6. Okay. This will become a little bit more clear now that I have this game engine pointer when I go to my player and I want to spawn a bullet. Now what I can do is, in my player, this is my player update function, I have an engine pointer now. And this guy I can call add object and add my bullet, like so. Now I have my engine, and this engine is accessible from the player. We have now successfully created this link from here, from the player, to the game engine. The player has a pointer to it. In fact, all of these things will have a pointer to the game engine. Okay? So watch what happens now. Before, when nothing was happening when I was pressing space, now you guys can see I am spawning bullets where my player was. Right? And it's working. So let me take all this code now. I have this code for spawning a bullet. Watch what I can do. Put it right here. And then I can get rid of all this code here. And I can get rid of all this code here. And I can actually get rid of all this code here too. I'm going to move all that code into the player. I'm going to take all that code that was here, I'm going to put it right here instead. Here's my code for moving. Now keep in mind too that I don't actually need to reference the player. I actually can just call set acceleration and set angle directly here. Fix up some code. Oops. So I can still move. Now when I shoot my bullets, there's all my bullets. I don't have my spawn interval anymore, my weapon interval, so I can spawn them as fast as I want to. But all this logic lives here inside the player, like so. So this is actually kind of neat. The reason is that now, watch what I can do. I can create a second player. And without doing anything else, I'm going to create a player 2. So this is going to be a 2-player game. There's my second player. I'm controlling him. And he's flying just like the first player. And each one of these guys can shoot bullets together. Okay. I've effectively been able to duplicate that code without having to do any more work. So I can take this to the next level now. I can create 10 players. So I can create 10 players that all move, and they all shoot separately. And all that logic is inside the player code. This is a super cheat mode for Asteroids. It's pretty awesome. What's interesting is that some of these players actually get out of sync a little bit. Like some of them slow down at different rates. You can see some of them are going closer and further apart. So we've done all that work. It looks kind of the same as what we had before, but the benefit is now we can add asteroids into our game. I want to get to the point where we have our game here. Let me show you what this thing is going to look like. Oops, wrong one. Let me show you what I want our game to look like here. Once I put all the sprites in here. So we're going to get to a point where our ship is going to be moving around like this, and we're going to shoot a bullet, and the bullet's going to hit the asteroid, and it's going to collide with it and blow it up, right? So this kind of looks like our diagram, although these asteroids unfortunately don't have names. We could probably draw names if we wanted to. But each of these bullets is handling collision detection. And the asteroids are actually running into each other, but they're not colliding with one another. Okay? So I have some work that I want you guys to do. We're going to create some behavior for asteroids inside of our lab. So let's take a look. We did this with the bullet. We have our player. We have our bullet. I want to create some work with the asteroids here. Let me take a look at this. Any questions so far on any of this stuff as far as how we're going to organize our game engine? Okay, so here's what I want you guys to do. I'm going to put this up on Zool, and I am going to have you guys do problems 1 through 3 to start. And the first one is going to be, I want you guys to take, there's a bunch of images in the engine folder. There's a bunch of pictures that are already distributed with it that you can use. So there's like inside here, there's a meteors page. You can pick any of these images, but what I want you to do is I want you to spawn 5 stationary asteroids randomly around the screen using our engine that we have right now. And then I want you to have the number 2 would be, there's a 50% chance of them being small or large, like so. And then the last one is, before we get to shooting an asteroid, because we're going to do the shooting part together, is we're going to spawn 5 moving asteroids that move in random directions. Okay. All right, so this is what I'm going to give you. I'm going to give you guys this, not the 10 players one, because that's kind of silly. I'll give you guys one that has 1 player in it. So I'll give you this to you guys on Zool. You'll have this, and you'll have a bullet spawning. And what I want you to do is I want you to add an asteroid class to this engine. Okay. Let's go here. I'll put this up on Zool right now. Sure, I'll head over as soon as I put the lab up on Zool. Okay, so on Zool, there's an engine that you can just grab the whole thing, and then there's also a lab. Just do 1 through 4, numbers 1 through 4, and then we'll do 5 and 6 together, okay?